So, a number of you have asked me about what do I mean by conservation law, and so I wanted to give a few examples of what we mean, since this is a common concept throughout many of the things we've learned in class so far. And I'm going to start not with one of the ones we've covered in class, but with one that's perhaps a bit more intuitive and familiar to you, which is the conservation of mass. So this might be familiar to you from chemistry, for example, or from just familiar contexts. And what conservation of mass essentially means is that mass isn't created or destroyed. And so if we have some initial mass of our system, and then some change happens, no matter what that change is, the final mass is still equal to the initial mass. So our initial mass is equal to our final mass. The sum of all the masses hasn't changed. Another way of saying this would be the sum of all the masses initial is the sum of all the masses final. So, for example, if I have two pieces of clay here, and I throw one of them at the other one, and then I end up with a bigger piece of clay. If my initial pieces of clay had masses of M1 and M2, then my final piece of clay has a mass of M1 plus M2. Or I can do this the other way, right? If I take my piece of clay here and tear it into two pieces, these two, M1 and M2, better add up to the mass of my M1 and plus M2 that I started with. So most of you are probably pretty familiar with this from either some other course or from your everyday life. So a conservation law is just this for anything. So a conservation law just means that some total amount of a quantity doesn't change. So when we have conservation of energy and we say that our initial total energy is our final total energy, that's all we mean, right? So in this case, we think of all the kinds of energy that we have. We could have KE initial and potential energy initial, and then we could have work that we put in, and that would equal our final potential energy plus our final kinetic energy. Okay? And all we're meaning here is that energy is a thing that's like mass. It can't be created or destroyed. So we've had conservation of energy. That's this one. In this course, we've also had conservation of linear momentum. And now things are getting slightly more complicated because we've got vectors, right? So we can have our total initial momentum is equal to our total final momentum. And now these things are vectors, but it's still the same thing. When we say conservation of linear momentum, all we mean is that the total momentum we start with is equal to the total momentum that we finish with. And this is also true for angular momentum. So angular momentum is also a conserved quantity. Angular momentum is a conserved quantity. And when we say that angular momentum is conserved, again, we just mean that our initial angular momentum is equal to our final angular momentum. Okay? So all of these are really the same. And so And so when you think of a conservation law, maybe you can remember conservation of mass and just remember it means that the total amount of whatever quantity is conserved doesn't change no matter what you do. Okay, that's it.